Important theorem we'll be discussing, that is called Clean's theorem. That statement is will like this: for any regular language L, there is a regular expression or the with L of R is equal to L. This can be done by construction of regular expressions. That means FSM to regular expression, I need to find out. There is an FSM, finite state machine, or finite state automata. From that you have to find out the regular expression by Clean's theorem. Right? Right. Look at this. A statement will be like this. There is a very important concept. This you may ask in exam. Important theorem also. Clean's theorem. The statement of this theorem is every DFA or a finite FA or FSM, there exists a regular expression EA such that L of A is equal to L of E, right? The proof will be like this. First, you need to take a number of states of automata. That means 1, 2, 3 to etc. n. Consider the R is nothing but a regular expression. Ij is a subscript, what is a path between I to j, and how many number of state it can rotate used in that regular finite state machine. So that means consider Rijk be the Re, whose the language is a set of labels of path from I to j without visiting any state with a label larger than k. With a label larger than k. K is indicated number of states. Right. So there is a two steps comes in this theorem. One is a basis rule, other one is a induction step. First you have to see the basis. Suppose any state, any transition between the state directly, that you have to collect it. Collect the what are the values or particular label is representing, a particular transition is representing with that path. Rij power 0 collects the labels of direct path from I to j. Suppose there is an n number of elements labels a1, a2, etc. n. If delta of I comma ak is equal to j for k is greater than equal to 1, n or less than equal to 1. Suppose if I is equal to j, then it also include epsilon. Whenever I is equal to, suppose the state will be, there is no transition, it will be transit that particular state itself, then you have to include the epsilon. That is the basis rule. What about the induction step? I need to compute Rijk using Rijk minus 1. So how to do that? What is the formula? So the formula will be like this. Rijk is equal to, so path is Rijk minus 1 plus, so Rikk minus 1 followed by Rkk minus 1 whole star, right? Whole star, right? Rkjk minus 1. So this is very important for expressions. You need to remember to collecting the labels, right? Labels. So as I said, remember this is a very important concept, important step for doing the problems. Next, how to represent? We have seen that in the previous slide with the basis rule and induction step. Those two formulas are expression. How to represent that in a graphical manner? Suppose I state and j state. So it in between the some labels are there. We have considered like that. So in between there is a intermediate states will be there. So say k states. What is the path between I to j? So k number of times it can be rotated. Okay, it can rotate it k number of times. So further it can be split into, take the I state, then j state, then k minus 1. This is a split like this, rij k minus 1. So you can compute with this. Further it will be split up it like this. What are the intermediate states? Suppose what is the state between this? What is the expression between? Look at that. rik k minus 1. Then this one is rkj k minus 1. Then what is that? This one, this is will be like this, right? So this path will be rotated. There is but r expression rotated is a self loop k is equal to k only, k minus 1. So you can represent it like this, right? Problem. So straight away I think the theorems have been discussed now in the previous two slides. Those to remember it for solving a problem. I will try to clear it some more doubt on you people. So how do you use that formula to collect the information by using a basis and induction steps? This is one simple problem I have taken. So there is a k is nothing but number of state. Here it is a q1 and q2. So I need to find out what is the regular expression is accepting by this finite state machine. As usual, I have to start with compute the rij. So this is I, you can say this is j, right? So I need to compute the what is the direct path between ijk. So now I take the r11. What is r11? So r11 is, that is this will be the r11. So it is I is equal to II, R is equal to II. I am collecting II. What is I? I is 1, I is equal to 1. So what is k? K is equal to 0. I am taking this k is equal to 0. I will write again here. So now I will take, how to get this, R I I. That means R11. So this is, if I say I, this is equal to j. Then what is k? So k is equal to 0. Then it is with 0. It is k. Suppose k r is equal to 0. Then how do you do that? So here it is II. The path will be going within that state only. Then what is the value? What is the value? 1. So plus, suppose your I is equal to I, it will go to the same state. Then you have to include epsilon, as you were told in the previous slide with the procedure. So like that we will get I is equal to 1 1. Once you understand this concept, let us move to the next one. Suppose k always is equal to 0, 0. So ij, that I can say it is a k. R0, I is equal to 1, j is equal to 2. This is I, this is j. Now what is the path? What is the value of this? This is 0. Right? Here I am not adding epsilon. Why? Because both are going to the, will not go to the same state, will go to the different state. Okay? Look at this. That is the value. Okay? Similarly, or it will from year to year, is there any transition from q to q1? No, there is no transition. Then I have to write pi. There is no transition, you have to empty transition. Then you can say I and j. Next, or it will go to this one. So now you have to tell me this state will go to same state. That means either accepting 1, 0 or 1. Okay. And also will go to the same state. Then you have to add the epsilon. So same thing we have seen. Right? Okay. So we have compute the direct path transition. Similarly, if you still have a path between the states by induction step, the compute Rij 1. So now k is equal to 1. So k is equal to 0 and k is equal to 1. So R11 you know already what R11. R11 you need to compute it. What is the formula I have to use here? So you have to formula, you have to use like this. How do you get this expression? I'll explain now here. Before to this, before to this, before to this, I'll explain. Okay. So this one is, I'll write here K I J induction step computation R I J k minus k minus 1 plus r I k minus 1 into r I kk whole star plus r k minus 1 jk. So this is the formula. You have to remember it. Okay, this formula I have shown in the previous slide by induction step. Okay, once you understand this, we'll see. What is a k here? K is equal to 1. What is I? Is equal to 1. J is equal to also 1. How do you take this? So k is equal to 1. I is equal to 1. J is equal to 1. Okay. So now I am substituting here Rij. Here it is k is k minus 1. So k minus 1 is, so k is equal to 1. 1 minus 1 is 0. So this power is clearly understand. So Ik and Ij is equal to 1 1. Then I have to do that. So now you have to substitute this value already computed. What is R110? 1 plus 1. Okay. 1 plus epsilon. What is R1? All this value are computed. You have to simplify this. How to simplify? You will get the anything you added to that, you will get only 1 star. So R11 is computed. So this part is over. What is R1 to 1 power? Okay, now I have to compute this value directly. 0 is over. So next it is similar formula I have to apply. I is equal to 1. This is I. This is J. This is K. Substitute the value for that. R120 plus R110 R120 then R star 0. What is the value of this? Already you know what is this value. Substitute this value 0 plus R1 0 plus 1 epsilon, then 0 plus, not 0 plus, I am clearing it, I am telling you this is I. J is equal to, this value is this 0 plus 1 plus epsilon star plus 1 0. It is 0. Right? Now you will get C like that. So this is the value. So whatever I am written it, same thing I am getting. If I simplify this using identity values as we have discussed in the previous slide, so that 14 identities are very important for simplifying it here. So now it is the common. What is the common here? Now 1 star. So what is the star here? So here it is, which is the common here? So 0, 1 plus epsilon into 1 plus epsilon star, right? So this one, if you make this is 0. So when I simplify this, this value will get 1 star 0. 1 star for this is 1 star you will get. Okay, so I can get this. Next is R21. What is this value? You already know that formula, substitute formula. We have computed these values already. It is with you. You can substitute directly and simplify. So what is the value you are getting? Anything it is multiply with a pi plus pi, it is pi only. Okay. So now this is a value, then R211 and substitute those value. You have already these values, just you have to substitute over there. So anything you have multiply with this, it is pi only, that is pi. Then what is these values? What is these values? We will get 0 plus 1 plus I, right? So when I adding this, you will get only these values. And next 2, right? We look at this value R112. So we'll get the same formula, right? K minus 2 means 2 minus 1, that is power 1, 1, 1. Substitute remaining values. So you already computed this value from the previous diagram steps, substituted over there. So all these values multiply with a pi, we will get pi only. Pi plus 1 star is 1 star. Okay. Similarly, so R12 over 2, you will get same thing. So you have to substitute these values. Now you can think over that. What is this value you will get? So what is the common here? So common, this between this you will get the 1 star only. R star is equal to R star, you will get R star only. So here it is, if I simplify these values here, it is a common, here it is this one. 1 star 0 plus 1 star 0 is a 0. In this here it is a epsilon, right? Here it is epsilon adding here. I am getting here 0 plus 1 star only you will get. So here it is, you have to multiply this value. Okay. We'll get these values by simplifying the value. Right? R212. So again you have to substitute this value. You know these values, you have to substitute. You will get this value. Whenever you multiply this value with this pi, then you will get the pi plus pi, this value. So last parameter you want to compute, that is our last expression. Substitute this value, and if I simplify, this is the common in between, you will get 0 plus 1 whole star you will get. Okay. Next. So how do you substitute this? Get the resulting regular expressions. What is the resulting regular expression? So always regular resulting expression, you have to compute these values. R12 over 2 will get these value. Substitute here, you will get the final result. That means, so final result 1 star 0 plus followed by 0 plus 1 star. Okay. So this is the final regular expressions. So why I am taking this is directly, I could have take these values directly. Okay. So this is the final value. Why I am taking here, this will be the final data I am taking from this. Okay. So this way you can compute those values directly. Okay, so now I think you can see some second problem. Find the regular expression following DFSM. Compute all this value. As usual, you have to follow the previous slides, and you can compute this. I am giving this problem for you to practice at home, and also I can take up this problem and take 2 more problem in the classroom on the notice book, on the blackboard. I'll clearly explain it. So with this is the pre-video. Just it is for you to glance it how to compute the regular expression from finite state machine. Thank you.